Okay, so today we are going to do a little bit more work with complex numbers. Um, we just did the real and the imaginary part in the last lesson, and then we talked about getting negatives out from underneath radicals. So now we're going to go the opposite way. So this says rewrite the complex number. I'm on page 56 in your books. This says rewrite the complex number 2i using a radical. So remember, a radical is that symbol. Okay, so we want to rewrite 2i. So it is, instead of in imaginary form, we want to rewrite it so that it's in radical form. So the I came out of the radical because there was a negative. So if you're going back in, that means there's a negative underneath the radical. And then the 2 would come from whatever we were trying to find the square root of. So here, if you think about like when we did the square root of -9, the negative came out as an I, and then we had the square root of 9. Well, the square root of 9 comes out as a 3, because 3 times 3 is 9. So now we're just doing the opposite. So here, this 2 is going to go back underneath as a 4, because the square root of 4 is 2. So essentially, you just have to take that number and multiply it by itself and put it back under the radical. So this is your final answer. It would be the square root of -4. And if you were to clean that up like we did the other day, you would take the negative out as an I, the square root of 4 is 2, and that's how you get 2i. So a couple more examples down here. If you want, a good idea would be to stop, write them down, and give them a shot on your own, or if you want to listen to me talk through them, either or, but do what works for you. So here, if we have 7i and we want to rewrite it as a radical, the I goes back underneath as a negative, and then the 7 goes back underneath. You have to multiply it by itself. 7 times 7 is 49, and that's your answer. Okay? If you were going the other way, the negative is the I, square root of 49 is 7. So then over here, this I comes underneath as a negative. This 6 goes back underneath as 36 because 6 squared is 36. Now, for this last one, we have a radical that's already there. So that is going to stay, but we need to take this 3i and bring this inside. So what that's going to look like is we have this radical, the 5 is there. The I comes inside as a negative, and then the 3 is going to go back inside as 3 squared, which is 9. So you end up with the square root of -45, and that's your final answer. So you still treat this 3i the same way as we did in the last two examples, but you have to take care of this 5 right here at the end. Okay, so that's rewriting using a radical. Essentially, it's going the other way than the last lesson. Okay, so now, sorry. Okay, so now, these are notes that you want to take. If you go to page 58, it should be blank at the top of the page. So, from what we did in the last lesson, we know that I is the same thing as the square root of -1. Okay, so if we were to take these three problems and evaluate them in your calculator, the square root of 7 squared is going to be 7. The square root of 31 squared is 31, and the square root of 846 squared is 846, because if you recall, kind of like subtraction undoes addition and multiplication undoes division and all that, a square undoes the square root and you're just left with whatever's inside. So we're going to use that knowledge to talk about what I squared is. So if we know that I is the square root of -1 and I want to know what I squared is, well, if I square both of these, I want to know, I know I is the square root of -1. I squared, well, I'm going to have to square the other side. These cancel, and you end up with I squared is -1. Okay, this is what you want to know, memorize, remember, etc., etc., that I squared is -1. Okay, because I squared being -1 is what we're going to build off of for the next part of the lesson. You're always going to see I written as I. You're never going to see it written as a square root of negative 1. We just have to use that to get to I squared. So here's the thing. I will always be I, and then I squared will always be written as negative 1. Okay, so essentially I is the only one that stays in imaginary form. Everything else we're going to convert. And we're going to do that here. So on page 58, right below that, these are the 4 examples that we're going to work through, and I'm going to do the exact same process every single time. And I'm going to use these 2 exponential rules that we talked about, the properties, last week. Power to a power, we multiply, and then if we have the same base and we're multiplying the actual term by term, right, the a to the m and the a to the n, then we add our exponents. So first we're going to focus up on this guy. Power to a power, we multiply. Okay, so the very first thing you always do when you have higher power I terms, I to the 32nd, I to the 82nd, things like this, you always start with I squared. Why do we start with I squared? Because we know that I squared is negative 1. That's all you need to know here in order to be successful with these problems. So we say, okay, I know what I squared is, and we're going to build everything off of that. So I squared, I say to myself, okay, power to a power, you multiply. So I to the 32nd, okay, 2 times what is going to get me 32? Well, 2 times 16 gets me 32. Okay, so essentially all I've done is rewritten this in another way. And why did I do that? Well, I know I squared is negative 1 to the 16th. And now this is easy. Think about when you multiply 1 times 1 times 1 times 1 times 1 times 1 times 1, you're just going to end up with 1, no matter how many times you multiply it. Well, this is the same thing as saying negative 1 times itself 16 times. So negative 1 times negative 1 times negative 1 times negative 1 times negative 1. Well, if you think about that, and you think about the fact that a negative times a negative is a positive, well, if I were to write this out, negative 1 times negative 1 times negative 1 times negative 1, and so on and so forth. Sorry, my computer hates me. Okay, all the way 16 times, I would say, okay, well, negative 1 times negative 1 gets me a positive 1. Negative 1 times negative 1 gets me a positive 1. I'm going to do that 16 times, and I'm going to end up having 8 pairs that are all 1. So essentially, it's going to be 1 times 1 times 1 times 1, right? 8 times. Well, I don't care how many times I multiply 1 by itself. The answer is just going to be 1. So that means I to the 32nd equals 1. Okay? So then, if we use that same logic and we go over here to I to the 82nd, again, you always start with I squared. I squared, well, 2 to what power gets me 82? 2 times what gets me 82? That's 41. Okay, oops, let's try and write that. Okay, so that's saying I squared to the 41st power, or negative 1 to the 41st power. So now we're doing negative 1 to the 41st. Well, when I do that, I'm going to end up with 20 pairs, right? Because 20 pairs will get me 40 negative 1. That's going to be positive. I have that 1 left over. So if I have negative 1 times itself 41 times, or an odd amount of times, I'm going to end up back at negative 1. Okay? So now we're going to apply that same logic down here. However, when you get down here, we have I to the 7th. So if I start with I squared, and I say to myself, okay, I squared, 2 times what gets me 7, that's a decimal. So that's causing a wrench. I would say, okay, 2 to what power is going to get me as close to 7 as possible, but not going over? Well, that's 3, because 2 times 3 is 6. Well, I don't have I to the 6th. I have I to the 7th. So 2 times 3 is 6. I need one more I to get me to I to the 7th. I'm going to let this I hang out, and then I'm going to clean this up like we did up above. This is negative 1 to the 3rd power. Negative 1 to the 3rd power, that's an odd power, so it's going to stay as a negative 1. Then you still have that times I. Well, negative 1 times I is just negative I. Okay. Same thing over here. I to the 401st power. Well, start with I squared. 2 times what gets you as close to 401 as you can without going over? That's 200. Because 2 times 200 is 400. We need one more I to get to 401. So we get negative 1 to the 200th power times I. Okay, this I is just hanging out. Negative 1 to an even power, everybody has a partner, so it's going to become positive. 1 times I is just I. Okay. Now, because of the way we're doing this with the powers and evens and odds, you only have 4 options. The only 4 answers you will ever get are either 1, negative 1, negative I, or I. If you're getting anything else, you need to check your work because you're doing it incorrectly. Okay. Now, if you need to, watch this part again. Make sure that you understand what's going on. Then turn to page 56. And I want you to work through example number 4 on your own. Pause the video right now. Okay, so now, in order to do this problem to check your work, we always start with I squared. Okay, well, this is odd, so I'm going to get as close to 57 as I can without going over it. That's going to be 28, right? Because 2 times 28 is 56. I need one more. I squared is negative 1. Negative 1 to the 28th power, every negative 1 has a partner pair, making sure that it all goes positive. So this, because it's negative 1 to an even exponent, is a positive 1 times I. Your answer should just be I. And you guys, the shortcut method, if you are unsure what I'm doing there, double check it in your calculator, but make sure you use parentheses. If you tell your calculator negative 1 to the 28th power like that, and no parentheses, it's going to give you a negative answer because it looks at it like this. You need to make sure that you get those parentheses around there. Okay. All right. Your other option right now, we're going to skip that for now, is to practice page 59, number 1 through 8, and you can check your answers in the back of the book. It's not for homework, it's just to practice what we've done over the past 2 days, and then your homework tonight is going to be a worksheet. Make sure you check all of your answers on Google Drive.